already familiar with this top definition here of a derivative, or the slope of the tangent line at a given point. It's the same thing. So I would like to just address for a second why this one and our alternate are really the same thing. So let's first look at a graph of our top one, f of x plus h minus f of x divided by h. If I set it up graphically like this, I can see that this is my point x2, y2, and this is my point x1, y1, based on this being x1 and this being the same thing as x sub 2. So looking at the slope, if I have y2 minus y1 divided by x2 minus x1, well, it looks exactly like this. x2, let's make it x2 minus x1. x2 minus x1 is this distance right here, h. y2 minus y1 is this distance right here. And so I have the slope. And as h approaches 0, that is, as these 2 points, well, actually it would be as this point here, as this point here gets really super close to that, I'm really finding the slope of the tangent at that one particular point. Well, let's take a look at the alternate definition for a second here. What I'm going to do is I'm going to change this point right here to be x, and this point right there to be a. So here is a, and there is x, and so the distance between them is x minus a. I think that's pretty clear. And so then this becomes the point a comma f of a, and this becomes the point x comma f of x. Or if I want to look at it like I was looking at it before, this I'm going to call my x2, y2, and this I'm going to call my x1, y1. So if I'm looking at my slope, I have y2 minus y1 divided by x2 minus x1. Well, isn't that the same thing as f of x minus f of a divided by the distance between those two, x minus a. So again, as x and a get closer together, as x approaches a, well, we can say in this case I'm going the opposite direction, I guess, although it doesn't really matter. As this point here gets closer and closer and closer and closer and closer to a, so the distance between those 2 points essentially becomes 0, the limit is 0, then I have the slope of the line at that particular point a. In other words, these two definitions are saying the exact same thing. They're trying to find the slope of the tangent to a curve at a particular point on the curve. The biggest difference, I would say, is that with my top definition here, what I end up with is an equation of the derivative defined in terms of x. So then when I want to find it for a particular point, I substitute in that particular point a, or whatever we might want to call it, and then I get the slope of the tangent right at that particular point. With this alternative definition, I'm starting with a particular point, so I'm getting the slope at that particular point. I'm not necessarily getting the formula in terms of x, although I would end up with it in terms of a.